All right, so let's take about 2 more minutes and we'll see how it's going. That's a lot of green, Shelby. Did you take it more than once? Okay. Nice work. I could be in trouble. I saw a lot of green as I walked around. Oh, that's not what I want. Oh, that was close. It's okay. That perfectly demonstrates my teaching abilities right there. All right, we just have one more. So I'm going to move on here in a second. Let's see. Maybe your class did better. Oh yeah, we killed it. Yep. So while you're waiting, it might be a good time to think, I should study the matching terms. Anyone know when the test is? It is Wednesday. So might be time since we average 60%. But okay, I'm just going to go ahead and talk through. I'm not going to cover, this one. The matching terms, the mode is right here, like 44%. That's what I was hoping for. No, but anyway, the 100%ers, fantastic job. I'm not going to go over much. Find the lowest one of all. $38. All right, so centimeter cubed, that's the lowest one. That's the unit of volume. Anyone remember from math how to calculate volume? Not density, just straight up volume. What's that? I swear someone said it. Length times what? Width times what? Height. How many fingers am I holding up? 3. So the unit better have a 3 on it because it's a cubed value. So volume, length times width times height, that's 3 things. So we have centimeter cubed. You all right with that? How do you calculate area? Tell your partners. What math-wise, how do you calculate area? Length times width, right, Gabe? What is this green concoction? What? It just looks unique. That's all right. All right, so it's length times width. So how many things are there? Length and width, that's how many? That's 2. Thank you for answering. So centimeter squared must be the unit of area. Okay, let's make those weaknesses your strengths. Just think how you calculate them, how many things you multiply, and that's going to be the exponent. Okay. I told her today, Tiffany, when we talked this morning, that the average would probably be below 50. So you rocked it. You blew me out. All right, now it's matching. Matching to me is always an indicator of how hard you try to study for the test. And look, I know the test is 2 days from now, so you haven't even put any effort in. No. All right, so let's, that's a lot of people on the honor roll, and we just averaged 60% on a matching section. All right, new man, do you know people's names? I usually just chuck them and show you my mad frisbee skills, but to conserve spit, they haven't sealed any of them, so they don't fly very well. I learned that the hard way. All right, so not bad, but make sure you study before Wednesday. That's why we do these quizzes now, is so you learn what you need to learn. Okay, next quiz. The kinetic theory of matter. We'll see how this one goes. Whoops, wrong one. I need the quiz, not the page. '86, that's a lot better feeling. We're at 90, that feels even better. So pretty nice graph here. So nothing too hard. Just if you can't find them quick, just say their name and they'll raise their hands. Good, Brownian motion, whatever. We're 100%. Everybody, the energy of motion is called kinetic energy. Like the chemistry spirit is touching me right now. Well done that we got 100% right there. 90, 100. You guys are geniuses. And if you're like, wait, I didn't get that question. That's how it works. Remember, it references a test bank. Ooh, this one was the only low one, really. The ability of a substance to penetrate into another substance is called diffusion. All right. So that's when the lighter colored beads and the darker colored BBs, technically, they were able to mix or penetrate into the rest of them. All right. I guess, is this honor roll? Because they used to give out candy with them too, but yep, no candy this year. Sorry, kids. Anyway, fantastic. I'm going to call that good enough, and we're going to move on. So hopefully you feel good about that. All right, we're going to wrap up page number 9, maybe. Got a whole. She's not here today, but all right. What? Page 7. At least it was an odd number. All right. So if you'll look on page number 6 and 7, we ended Friday, which I know school years, that was like forever ago, but yours is unique. Help him figure out his lab book. So we talked about the scientific method and experimental design boxes, experimental design concepts, I should say, on page number 6. Those are the things that we use to make sure our experiment is defendable, that we get good data that we can then present and be able to defend it. And we can repeat and repeat and repeat. So what we're going to do, we're going to take the 5 things that you can see on the bottom of page 6, and we're going to fill in what we call experimental design boxes. Now you have to do some of these in your homework. You have to do one of these on the test, like for the next 3 tests in a row. We will use them all year long. They are just organizational tools. They're not something you should hate. It's like I hate a hammer because I don't like building houses. Well, it's not the hammer's fault. It's the tool you use. All right. You may not enjoy filling these out, but this is just a tool to help you organize. So if you recall on the bottom of page 6, we talked about a variable, okay, that it was something that could change. And then we talked about in the scientific method early at the very top, we said that a problem was something we wanted to figure out. Then back to the bottom, we had 1, 2, 3, 4, 5. We had the IV, which in an experiment, I changed the IV. All right. So if I wanted whiter teeth, I would change the toothpaste I used or something like that. Then the DV, that's the thing you measure. So in my experiment, I would measure the whiteness of my teeth. All right. And then underneath the IV, we have constants. So those are, or sorry, yeah, constants. Those are the things that we got to keep the same. So if I'm trying to whiten my teeth and prove which toothpaste is best, I can't like brush more. I don't know why that did that. I can't change anything. I hope it doesn't just keep on doing that. That would be annoying, wouldn't it? Anyway, so we have constants. Those are the things we keep the same, and they're really important in a lab. And then we have control. I wouldn't like break a tooth out and not brush it. That'd be stupid, but it would be the thing we would not test so we could compare our test to. And then repeated trials is how often we do it. Okay, using that, we're going to fill in the top of page number 7. So we're just looking for these specific things that we can put into this experimental design box. So number 1, we have this experiment. Our good friend Erica, she wants to figure out the amount of vitamin C in orange juice. So if I were to ask you, what does Erica want to figure out? Could you tell me? Tell your partner, what does Erica want to figure out? All right, how many vitamin C in different types of orange juice, right? Well, that's the problem. That's what you write at the top where it says problem. The title of the scenario almost always tells you what the problem is. Now, problem has a lot of negative connotations in our life, but problem really means what do we want to know, or what does Erica want to know? She wants to know which type of orange juice has the most vitamin C. Okay, so the problem is always like, what am I going to do in this lab? What am I trying to figure out? I'm trying to figure out the amount of vitamin C in different types of orange juice. Okay, as you read, Erica's chemistry class was studying a unit on acids and bases. They investigated the amount of ascorbic acid or vitamin C in a solution. Erica's lab group decided to experiment with the amount of vitamin C in types of orange juice. The type of orange juice they chose were fresh, frozen, and bottled. They collected 100 milliliters of fresh, 100 of frozen, and 100 of whatever from a vending machine. Using an established procedure, the students measured the milligrams of ascorbic acid in each sample of juice. Okay, so the next step down, we know the problem was the amount of vitamin C in different types of orange juices. Well, you turn to your partner and say, all right, well, which of the 3, fresh, frozen, or bottled? How come I'm having it? Oh, there's a hole in these shorts pocket. Take a guess. Discuss which one do you think has the most vitamin C of those 3? Now, what if your partner disagrees with your hypothesis? Does it matter today? No, just write one. So you would write whichever one you feel has the most. Or you could say the least. Your hypothesis, the way you frame it, is up to you. All right? So basically, you could say any of the 3 has the most and just pick one. Any of the 3 has the least and pick one. Or there is another possible hypothesis. Any guesses? They're all the same. All right. Now, if I were doing this experiment, I changed the IV. Tell your partner in this scenario, what is Erica's group going to change? Okay, I'm really good at hearing the people in the front row, about right here. And I looked for lips moving, and like most of the room is not answering any question with their lab partner. Some of their lab partners are absent today. So Shelby, Garrick's going to need some lab partner help, okay? All right. So please, this class will be super boring if you refuse to ever talk to the people next to you. All right. So if I were doing this lab, I'm in Erica's group. I would change the, oh, this is upside down. the type of OJ. You got to know this for your test. You can Snapchat all you want, but your test score won't be good. All right? The type of OJ. When you read these, you look, hey, what are they going to change? It's right in here somewhere. It's like all in here and in here. Type of OJ. Is there a unit for a type of orange juice? Tell your partner yes or no. No, there's not a unit for the type of orange juice. So just put NA. That means not applicable. Okay, TRT. That is short for the word treatments. Treatments, if you look on the bottom of page 6, those are the ways you change the IV. So I just look right here. How did I change the type of orange juice? Erica had 3 different types of orange juice. Write those in right there and then show it to your lab partner. What 3 types did she use? Okay, very good. Thank you. No, I like that purple green phone case. I wasn't picking on you. I genuinely liked it. Uh-huh. Fresh, bottled, and frozen, right? Okay. Number of trials. That's how many times they repeated it. Did this say they repeated it ever? No. If it does not say it repeated it, then you just assume they only did it one time. Now, sometimes they will sneak in, like it won't say, and they repeated it, but it'll say they poured 6 cups of each one. And then, well, that would be 6 trials. You okay with that? It might be hidden in there. So make sure you be careful. Okay, the IV is the thing we change. The DV is the thing that we measure. So we change the type of OJ and we're going to measure something from this top sentence. What are we going to measure? All right, good. Amount, vitamin C. How'd you enjoy the family party that you didn't come to? Pretty good? Yeah, it was great. Haven't I already asked him that in this class? Yeah. Garrick's 0 for 2 on family parties this school year. We'll see it the next one. Yeah, well, that's like the last party. No, we got the Halloween. Never mind. Okay, the amount of vitamin C does have a unit. Will you look up here or on your paper carefully and see what unit you think they're measuring the amount of vitamin C in? It's 50-50. All right, I will give you a hint. It starts with an M. Oh, really? We have milli, and it's either liters or grams, and it's a gram. And I'll tell you why. This milliliter, which most people guess is this, that's how much orange juice they measured, but they measured the vitamin C in milligrams. Okay, kind of subtle, but be careful. Okay, then constants. I will ask you, hopefully not in vain, will you tell your partner at least one thing that they better keep the same? All right. Derek says the most important one, which some of you probably said too. He said the amount of orange juice. Because if I get a gallon of one and a teaspoon of the other, they're going to be different, right? So the constants, the amount of OJ. All right. Van said OJ, so we better not switch to apple juice or something like that, right? So you don't have to write all these, but you could say the same juice, whatever. Any other ideas? Go ahead. Temperature, absolutely important. When we do these, you can almost always say for a constant that you need to keep the same temperature. The only time you would not list temperature as a constant is if it's your IV or your DV. But other than that, you can always use that one. Okay, anything else? Okay, there's tons of things. On the test, you have to list 3. If you're stuck, say same planet, same pressure, same day, same attitude, same scale, same whatever, name it. Any tool that they used, you can name it. Temperature, almost always. Pressure, almost always. Anyway, okay. And this, there's always basically one answer here that always works. How could you have improved this experiment? You won't think about it, but once I tell you, you're like, oh, that makes sense. There's one huge flaw to this experiment. Anybody know what it is? They only did it once. Perfect. Fantastic. So the ways to improve it is repeat trials or more trials. I don't know what I even wrote here because I was not looking. So more. If you do more experiments, you'll get closer to the right answer. More. Okay, easy-ish. I guess not the hardest thing we're going to do all year. I understand it takes time. Here is Jake and his hot tub. Will you do it? We did one together. What I want you to do is I want you to do this on your own for 3 or 4 minutes, and then I want you to check with your lab partner and see if you guys match. So if you would do that, I'll start a 3-minute timer. Nice job on that. Most people don't notice that. All right, some people get stuck when it says possible hypothesis because they're like, well, what type of sealant is he using? I don't know, make it up. Like Davidson, Burt, and Miller. And then clearly your hypothesis would be Davidson is the best. Okay, Walmart, Home Depot, Lowe's, brand 1, brand 2, brand 3. Perfect, Maddie. So don't stress there. If no one puts their hypothesis that Davidson is the best, I will be offended. If they put Davidson is the worst, I have some transfer papers. They should. Can I look, my friend? Sweet. Way to listen, my friend. You only have one thing wrong. It's that one. They stuck a different number in there. Okay, let's wrap it up in about 30 seconds here. Oh my gosh. Bert is best. Get. I've never been sadder in my life. Okay, I have actually, but I'll remember that. Okay, let's check the lab partners. Do that part. I forgot. If your lab partner did not get done, we'll go over it. Nice. That's the thing you change. So which water sealant works best? So what we're going to change is the water sealant. So that goes right there. All right, I'll go here. Let's do this together. The goal will be able to read my writing. We'll go blue today. The problem, what does Jake want to know? His problem is how much, never mind, I'm not going to finish that sentence. It's going to say how many girls you can fit in a hot tub. But moving on. The problem is which sealant is best, right? You don't want to ruin your new deck because your new hot tub in your new house because you moved to Manaway and you're cooler than everyone else. That'd be tragedy. Okay, possible hypothesis. Well, it helps if you know which one of your treatments. So I'm going to say Tom, Peter, and Andrew. We all three make different types of water sealants. Clearly, my possible hypothesis would be Tom is the best. Okay, moving on. The IV is the thing we change. So right up here, Jake wants to know the effectiveness of water sealants. So the thing he's changing is the type of water sealant. There is no unit for that. Non-applicable. All right, number of trials. Most people get this one incorrect on this one. If you look carefully, he says right here, he dipped 2 blocks in each one of the 3 major brands. So the trials is 2. Okay, kind of foreshadowed that, but a lot of times that one's hard to see. All right, but it is a 2. Bless you, child. Okay, the dependent variable is the thing that he's going to measure at the end. So he soaks the blocks, they absorb water, and he's going to find out the amount of water absorbed. All right, then this one that does give the unit, it's right here. It tells us that he measured it in grams. Lilia, constant better be what? What? The temperature, right? The temperature. What else? Okay, type of wood. All right, new man. All right, good. Drying time. Like if you dried one for 3 days versus 3 hours, they'd be very different. All right, there's plenty more. You know, the way he applied the sealant, all right, the place he put them all to dry, like the humidity, all sorts of things have to be the same. Then I don't know, what are some ways that they could do this? Rhymes with pour, files. Okay, I think I'm funny. You don't even have to, but you could put more trials. You could put more types. You could put that he tested it on different types of wood. Like you can put all those if you feel like it, but more trials is the #1 way to make an experiment more valid. When I was a kid, 2 guys from the University of Utah announced to the world that they had discovered how to have cold fusion, which was an unlimited energy source without putting energy really in. It was going to change every single thing about our world. But there was only one problem with Mr. Pons and Mr. Fleischman. They could never repeat it, ever. So they made this huge announcement. It was a gigantic deal, and then they could never get it to work again. So most people don't believe that they ever got it to work the first time. You have to repeat stuff to get science to work. Okay, turn the page. There are 2 more scenarios. You with me? Okay, will you take, I don't know, we get out of here in 15 minutes. Will you do one and your lab partner do the other? And then switch data. You with me? We can do that fast. So you decide top or bottom and then have at it. Okay, so as long as you have both those filled in on page number, whatever that was, 7, right? We should be good. Page 8, you don't fill anything in on page 8. We will talk about it tomorrow, but there's no notes on it. So like when you're going to turn your lab book in, you're like, oh, sorry, page 9, page 9. When you're like, I don't have anything written on page 9, that is completely normal. Okay, so head to page 11 now. And in the last 6.5 minutes, we're going to fill out or discuss a lab that we're going to do tomorrow. We are going to make little test tube rockets using baking soda and vinegar. It's like the 2nd grade reaction. My kids were actually doing it yesterday in my backyard because we're nerds at my house. You could probably tell if you've met my children. All right, so it's in the other room, but tomorrow, try and listen to everything I'm going to say. Tomorrow in the fume hood, and actually around too, just to save time, I'm going to give you some vinegar. That vinegar is just straight out of the bottle. And if I were you, I would call that vinegar 100% vinegar. Now, it's not, but we can assume it is. It's the one I'm giving you. What we're going to do is make little rockets like this. You're going to take a test tube. You're going to fill it with some vinegar. Then you're going to put a little piece of toilet paper here that you're then going to fill up with not a ton, a little bit of baking soda. And here's something I'm going to tell you. I don't care how much baking soda you put right there, but it better be what? Tell your partner. Starts with the S. Better be the same every time. The amount of baking soda better be the same. And down here too, I don't care how much vinegar you have, but better be the same. So the amount of liquid better be the same. All right. Then what you're going to do, you're going to put a cork right here. And that cork would push the vinegar and the toilet paper under here now. And then you invert it. So you have a test tube with vinegar in the bottom. Then you have a layer of toilet paper that's going to hold your baking soda. Then you cork it, and then you go over the sink and you turn it over and you time how long it takes for the cork to blow off. If you hold the cork, It'll shoot up and hit the ceiling. And if you look right there, there's dents in my ceiling from this lab. If you hold the test tube, it shoots the cork into the sink. I don't really care which one you do. It's probably more fun to go that way, but it's also more messy. So it's up to you. All right, what we're going to test is how changing the concentration, oh boy, how changing the concentration of vinegar affects how long it takes the cork to blow off. That's all we're doing. We're going to make these rockets over and over and over, and I'm going to change one fundamental part. What fundamental part am I going to change? The concentration of this vinegar. Am I going to change how much of it I put in? No. I'm going to change the concentration of it, and I'm going to time how that affects the time for the cork to blow off or the time for the reaction to happen. Okay? So I feel I've given you a lot of information that you could fill out an experimental design box with. The problem at the top is, what am I trying to figure out? And you don't have to draw it as a box if you don't want to. So you would just write problem, and then you'd say, what are we trying to figure out? Well, what am I changing and what am I measuring? That will tell you my problem. So see if your partner listened well enough that you can figure out what I'm trying to figure out. I'm going to give a ton of you a hint. Your problem usually should start with the word how. Yours is still a question, so that's okay. So right here, write the word problem. Yeah, you're just filling in one of these. Oh, I have it right here, actually. So you're just going to fill in problem. How does affect, or is it effect? I don't care. Okay, now you may have written it a little bit different, but most likely you have something like this. So when we say how does whatever, this is the thing I change. And you don't have to write that. But if I'm doing this experiment, what's the thing I change? I change the concentration. Now, my friends, the word concentration sucks to write. And chemists know that writing the word concentration sucks to write. So we have shorthand for concentration, and it's brackets. Anytime you see that, they should be the same. Don't worry about my drawing skills. That means the word concentration. So how does concentration affect? Well, there's a lot of ways to put it. How long it takes the cork to blow off or whatever. I'm going to write the reaction rate. And there's another shorthand thing. Reaction, RXN. That's shorthand for the reaction. Okay, the possible hypothesis is up to you and your lab partner. Tell them real quick, how do you think concentration will affect the reaction rate? Okay, almost everyone says the same thing. You'll test it. Probably the higher the concentration, the faster the rate. Now, the IV, what am I changing? Okay, we'll get the rest of that tomorrow. You guys are great. Hey, please start studying for the test on Wednesday. Study those matching terms. You can find them on the front page. You can find them on page 4, all those things you need. Come on.